Hi trigonometry class, those people that weren't there in school today. These are help for your notes for Monday, June 2nd. So if you weren't there, hopefully you have printed off this note page from the portal. It's the Algebra of Trigonometry notes. And we're going to go through them today to try to keep you caught up so you're not missing things. So if you look at the top of the page, it says, in a previous discussion, you were asked the following question. Determine the values of theta that make the statement true, and it gave you that the cosine of theta equaled 1/2, and it told you that theta was in between 0 and 2 pi. And so what you would have done in the past is you would have grabbed your trusty unit circle, and you would have looked for where the cosine of theta is 1/2. And we know that we have a positive cosine in both the first and the fourth quadrants. So if you take a look there, hopefully you found it, that your response would be at pi over 3 and also 5 pi over 3. Now remember, if it's talking to us in terms of 0 to 2 pi, not 0 to 360, then you want your calculators to be in radian mode because we're dealing with radians. So now what we're doing is we're just going to condense this down. So we used to ask for the two values where the cosine of theta was 1/2. But for this time, we're only looking for the main or the primary interval. So we're just looking for one value of theta. And I'm going to help you figure out what the primary intervals will be for each of your functions. So that's this part right here. When we're talking about cosine, if we're thinking about all the values of cosine from +1 to -1, every single one of those values of cosine can be found on the interval from 0 to pi. Right? Because in quadrant 1 I get all the positive values of cosine, and in quadrant 2 I get all the negative values of cosine, and then when I look at 3 and 4, it's just a repeat of all those values. So really, I get every value of cosine that exists from 0 to pi. And notice these are the squared off brackets. That means it includes 0, it includes pi as one of the values. If I think about sine, however, if I were to go on this interval of 0 to pi, in the first quadrant I have positive values, and in the second quadrant I have positive values. So that interval isn't going to tell me all the values of sine. Now, we're trying to get one cohesive interval that goes from start to finish. And so what I want you to do is I want you to look at your number line, because where I do have negative values are down here in this fourth quadrant. And so what you might want to do is you might want to go, oh, well, that's from 3 pi over 2 to 0 pi. But if I'm thinking about it in terms of a number line going from one low end to one high end, this going from 3 pi over 2 to pi over 2, that's not a cohesive group, because let's talk about it in terms of degrees. I'm going from 270 to 360 and then from 0 to 90, so that's not like a clear number line. So what I want to do is I want to think about this in terms of negative angles. So my primary interval for sine is going to be from negative pi over 2 to positive pi over 2. And that will give me everything in this fourth quadrant and this third quadrant. So I've got from negative pi over 2 to positive pi over 2. And then if we're going to talk about tangent, tangent actually is going to be the same as sine. Because what happens is, if I'm going from negative pi over 2 up to here, I will cross over right here, and my tangent here is 1, and 1's a good value, that's safe. The only difference is going to be, when I write tangent, my interval now is going to be with the curve brackets, because I'm not including negative pi over 2 or positive pi over 2. Because what happens here is that my tangent is undefined, so I don't want to include that in my interval. So I'm going from down here, very close to that, all the way up here, very close to that, and that's going to give me all the positive and negative values of tangent. But I can't deal with those because it's undefined. If we look at the reciprocal identities, secant is going to go with cosine. It has the exact same interval as cosine. The only difference is that at secant, I don't want my theta to be pi over 2. So I can use everything from 0 to pi except for pi over 2, because when I take the reciprocal of cosine of pi over 2, I get an undefined value. Sine, I get the same thing, except that I'm not going to have it at 0, because at 0 my secant is undefined. Cotangent, though, that changes. Cotangent, I'm now going to go from 0 to pi. And the reason why is because if I think about this, when we had tangent, I went from down here to up here, and I crossed over where my tangent was 1. And these polar ends were my undefined. Well, now that I've changed it from here to here, I've got undefined on this side and undefined on this side. This is going to be my 1 because I'm taking the reciprocal values. So that is my intervals. Now these intervals you don't have to have memorized. I just want you to have them down, and I want you to be able to use them for your answers. All right, so let's take a look. One more thing in the middle of your page where it says new symbolism. You can see where it has the sine to the raised to the negative 1 of x, and we always said that was sine inverse of x. And what that was asking us was, when we were putting that into our calculator, sine inverse of whatever, we were trying to find what angle has this sine, or what angle has this cosine. This is just a new way of saying it. Arc sine is the exact same thing. So if you see arc sine or you see sine inverse, it is the same. All right, so let's look at the bottom of your page and try a couple of examples. We're going to look at number 1 first. We're trying to find cosine inverse of 1/2. And remember what this is asking us is what angle has a cosine of positive 1/2. And so if I pull out my trusty unit circle, I can see that I've got 2 places where my cosine is 1/2, at pi over 3 and also at 5 pi over 3. But I want it in the primary interval. So that means I'm going to only be going from 0 to pi. So the only answer I'm going to give right there is pi over 3. The second one that is on that is arc sine of negative square root of 3 over 2. So if I were going to put this into my calculator, this would be the same as sine inverse of negative square root of 3 over 2, but we don't need to do that because we have our unit circle. So we're going to find where I would have a negative square root of 3 over 2 for sine. It's at 5 pi over 6. It is also at 5 pi over 3. However, neither one of those is in my primary interval. Remember, it needs to be in between negative pi over 2 and positive pi over 2. So notice on my unit circle, I have the negative values. So what I have down here is, instead of 5 pi over 3, I'm going to give my answer as negative square root of 3 pi over 3. So that would be the answer for number 2. So what I would like for you to do for homework tonight is to finish these, try 1 through 6, and that would have you ready for tomorrow. We have one more part. If you turn over to the back, solving trigonometric equations, we're going to work 2 of these out so you can see what we do. These are equations with trigonometric functions in them, and what we're trying to do is to isolate the trigonometric function so that we can get that by itself so we can solve it. So I look here, cosine of x is being multiplied by 2. It is also being added with the square root of 3. And what I want to do is the inverse order of operations because I'm trying to undo things. So I'm going to subtract square root of 3 from both sides. That's going to give me 2 cosine of x equals negative square root of 3. I'm going to divide both sides by 2, so that will give me cosine of x equals negative square root of 3 over 2. So to solve for x, I'm trying to find out what angle has a cosine of negative square root of 3 over 2. And if I look at my unit circle, I know that that is 5 pi over 6. Remember, we're talking only primary intervals. So when it says primary interval, I want my answer to be from 0 to pi. If I asked you to give me the domain, if I told you my domain was 0 to 2 pi, that is telling you I want all the values of theta that have 5 pi over 6 in the entire unit circle. So then I'm looking for two values. So my other value would be 7 pi over 6. So if I'm looking for the primary interval, I just want the one value. If I give you a domain 0 to 2 pi, I want both values on the unit circle that works for. Let's just work one more quick example problem. That's going to be number 3. Number 3 was 4 cosine of 2x, or cosine of x plus 2 equals cosine of x plus 1. Now, if I'm trying to isolate my cosine of x, I need to get them on the same side. So I'm going to subtract cosine of x from this side. I'm also going to subtract cosine of x from this side. So what I end up with on this side is 4 minus 1. That gives me 3 cosine of x plus 2 equals 1. And I do exactly what I did in my last equation. Subtract 2 from both sides. So I get 3 cosine of x equals negative 1. Divide both sides by 3, so I get cosine of x equals negative 1/3. Now this isn't something that's going to show up on my unit circle as a nice even number. So I'm going to need to put that into my calculator. So remember, we use the cosine inverse of negative 1/3. And what should come out is that x equals, I believe it's 1.91 radians. So remember, we are talking radians. So if I were just discussing the primary interval, I would be good, because remember when we did way back when radians, here was 1 radian, here was 2 radian, and so forth around the circle. And 1.9 radians would be in my primary interval from 0 to pi. Now if I wanted both values, then I have to find where I have a negative cosine again, and I know that's going to be down here. So if I think about where 1.9 radians is, probably somewhere up there, and I know that I would then have a reference angle somewhere down here. But I have to figure out what that value is. So just a quick reminder of what we used to do. We would say this is pi, this is 3.14 over here, right? This is 0. So if this is 1.91 radians, then to find how far up this was would be 3.14 minus 1.91, and that would give us a value. I believe it's like 1.23. So this is 1.23 radians up. So if I were going to find what this one is down here, remember from here we add 3.14 plus 1.23, and that gives us 4.37 would be our other value. So our two values would be 1.91 radian and 4.37. So remember, when we were going up, we subtracted, down we added to 3.14. So your final homework is just to do both those sections, the one on the first page, the one on the second page, 1 through 6. And if you have any questions, feel free to email me. Thanks a lot, guys. Bye.